To finish up this section, we're going to look at compound interest and how to find compound interest. I have the formula given for you here, and I'm going to walk you through what everything means and what this formula actually gives you. But I do want to make one note up front. Your textbook uses a version of the formula where you do not have to first turn the rate into a decimal. Most textbooks, and this is going to apply for those of you who may have seen this compound interest formula before, most textbooks have you first turn that interest rate into its decimal form. So if you've seen this formula before, you probably would not have seen the 100 in the denominator of this fraction. That 100 is simply there because it's not having you turn the rate into its decimal ahead of time. You may have seen this formula before where it looked like this. And to be honest, I think this is probably a little easier to use. This just means the rate is going to be in decimal form ahead of time. With this one, the rate stays as a percentage when you first put it into the formula. Hopefully that makes sense. So what does this give you? This is going to give you how much money you have in accounts. Let's assume it's an investment. Let's be positive here and it's not a loan. Let's say that I put $5,000 into an account for 10 years at a certain interest rate. This formula is going to tell me how much money I have at the end of those 10 years, assuming I don't touch anything. I don't put any more money in. I don't take any money out. If I just leave it be, this formula tells me what I have at the end of that time. P stands for principal. That's the amount invested. So if we look at this first example, it's talking about a $2,500 investment. That's the principal. 5.25%, there's the rate. So that's R. N is the number of times interest is compounded. So compounded, simplified, just means how often is interest calculated a year. If it's compounded annually, that means it's compounded once a year. So our N value is just going to be 1. And then finally in the formula, T stands for time, the length of years. And in this case, it's 7 years. This is all calculator work. And you do not need a fancy calculator to work these problems. Just a simple scientific calculator is sufficient. So before we plug into the formula, depending on which version you use, if you're using the formula as it's given, you would put 5.25 in place of R, and then keep that 100 in the denominator. And in my notes that I have posted to BlazeView, I've done it that way. For those of you that might be familiar with the other version of this formula, that's how I'm going to do it on these videos, just so you can see both ways, and they do work out to be the same answer. So if I'm using the second version of the formula, I will first turn R into its decimal form. So when we plug in, we're going to take our principal. And then in the parentheses, it's 1 plus, and again, the rate in its decimal form is going to be 0.0525 divided by n, which is 1, and then raised to the 1 times 7, or just the 7 power. Once you have that formula written out, it is all calculator work. And let me turn my calculator to a scientific version, because we will need to raise to a power. So if you have a nicer calculator, if you have a graphing calculator, or even some nicer Texas Instrument calculators, you can enter all of this in one fell swoop. For those of you that do not, I'll show you how you can enter this into the calculator a bit at a time, but you can still leave the whole thing in the calculator. So what you want to do is you want to start in the parentheses and start with the fraction. In this case, it's very straightforward. When you take 0.0525 and divide it by 1, you still have 0.0525. So you're going to start with that fraction and then add 1. So I have 1.0525. Now I'm going to raise to the power. In this case, it's the 7th power. 1 times 7 is 7. So your calculator will either have a button that looks like this. Here I have x to the y power. But your calculator might also have a button that looks like a caret or an up arrow. Either way, that's going to give you your exponent. So I'm raising this to the 7th power. Whenever you raise, when you're dealing with compound interest and you raise to the power, you're going to get a long decimal. That's totally normal. This now takes care of everything from the start of the parentheses to the end. The last step is always going to be multiplying by the principal, so in this case, times 2,500. And we're dealing with dollars and cents here, so we're going to round our answers to dollars and cents. If you leave this $2,500 in the investment, you don't touch it for the full 7 years, at the end of that 7 years, you will have $3,576.80. And the higher the interest rate, the more money you'll have at the end of the time. And the longer the time, the longer that money sits, the more money you're going to have at the end. So let's do one second one here. This time we have $8,000 invested. That's our principal. The rate is 7%. This is compounded semi-annually. That means twice a year. So our end value is 2. And the time is 10 years. So plugging into the formula, we have 8,000. In the parentheses, it's 1. I'm going to do the rate in its decimal form, so that's going to be 0.07 divided by 2. And then we're going to raise this to the n times t power, so the 2 times 10 power. Just like before, I'm going to go to the calculator and work the whole thing in there. So starting inside the parentheses, and then specifically starting with the fraction, I'm going to take 0.07 and divide it by 2. So you get 0.035. Add 1 to that. So now you have 1.035. And then we're going to raise to the power. In this case, it's going to be the 20th. 2 times 10 is 20. So I'm going to raise that to the 20th power. I get a big long decimal. That's totally normal. Last step, as always, is to multiply by the principal. So I'm going to multiply by 8,000. And here you'll see we have just about doubled the money. So in 10 years at 7% interest, compounded twice a year, you let that money sit, you will have $15,918.31. And that wraps up the section, and that wraps up the class. If you have any questions, please feel free to send me an email.